Welcome back to Wildcat Academy. Today we're going to be solving rational equations. There are two different methods to solve rational equations. You can condense the ratio on each side of the equal sign into a single ratio, making a proportion, and then cross multiply to solve the equation. The other method is to multiply each term by the common denominator. In examples 1 and 2, we'll be using the proportion method. So each side is already condensed into a single ratio. So all we have to do is cross multiply. So we will multiply 8 times x. We get 8x, and then 5 times x plus 3. And we will distribute the 5 and get 5x plus 15. Then we will subtract 5x and get 3x on the left-hand side is equal to 15. Divide by 3, and you will get x is equal to 5. Now, with proportions or rational equations in general, we always have to check and make sure that we do not have a value that is excluded, causing an extraneous solution, because extraneous solutions can exist in rational equations. And we can see we can plug this back in. We get 5 over 5 is equal to 8 over 8. There are no complications caused, so our solution is 5. In example 2, we have each side already condensed, so we will just cross multiply, and we'll get 5 times x squared minus 1 is equal to 15 times 2x minus 2. We will distribute each coefficient. We'll get 5x squared minus 5 is equal to 30x minus 30. Now, we have a quadratic equation that we must solve. There's multiple methods that we can use to solve this, but I'm just going to take everything to the left-hand side. 5x squared, we're going to subtract 30x. We'll add 30 to the negative 5 and get positive 25 is equal to 0. See if we can factor this. I'm going to go ahead and factor out the 5. Get x squared minus 6x plus 5. It does look like it will factor. So we will factor this into x and x. Factors of 5 are 5 and 1. Looks like they multiply to be positive and add to be negative, so it'll be negative 5 and negative 1. From there, we will set each factor equal to 0. Get x equals 5, and x minus 1 equals 0. X is equal to 1. So now we have to check our solutions to see if any of them are extraneous. So we can plug in 1. So we'll check x equals 1 here. 5 over 2 times 1 minus 2. This creates 5 divided by 0. And we also get 15 divided by 0. This is not possible. The division by 0 is undefined. So this is an extraneous solution. We can check x equals 5. 5 over 2 times 5 minus 2 is equal to 15 over 5 squared minus 1. That's 10 minus 2, which is 8. That's going to be 15 over 24. That is an equivalent expression. So that one checks out, and our solution is 5. In examples 3 and 4, we'll be multiplying through by the common denominator, effectively eliminating the fractions. So we will multiply every term by the common denominator. The common denominator of x, 2, and 2x is 2x. So you can think about multiplying every term by 2x. We're going to distribute the 2x into all three terms. It would also be helpful to write out that step. Something like that. Simply because whenever we're canceling our denominators, it makes it easier for us to track what is left. So we'll cancel the 2, we end up with x times x, which is x squared. And then the entire 2x cancels here, and we end up with x plus 4. We have a quadratic we're going to solve again. So x squared minus x minus 2 when we put it in standard form. We will factor that into x minus 2 and x plus 1 is equal to 0. We will solve this. X minus 2 equals 0. Gives us x equals 2. X plus 1 equals 0. Gives us x equals negative 1. We have to check both of these solutions. We can see that these are going to work out. Our excluded value is 0 here, so that is not one of our solutions, but you can go through and you can check that if you want to. You can get 1/2 plus 1 is equal to, that's 1.5, and then you plug in here 6/4, which is also 1.5. Use something very similar with negative 1. So our solutions to this problem will be 2 and negative 1. In example 4, we have a little bit more complex denominator. We want to fully factor this denominator so we can see so we can find the common denominator. And what we will be multiplying by, we'll multiply through by b plus 1 times b minus 1. We'll multiply every term by that. It does take a second to write out. But again, writing out does prevent us from making errors whenever we simplify. So you can see that the b plus 1s will cancel. We're left with b minus 1 in the first term. The b minus 1s will cancel. And I'm left with b plus 1 in the second term. Both cancel on the right hand side. Left with equals 2. That will give us 2b is equal to 2. B is equal to 1. We can go back and look. If we plug in 1 into this second term right here, we can see it creates division by 0. This is an excluded value of our equation, so that will not work. So b equals 1 is the solution we found. It is not acceptable. It's an excluded value, or an extraneous solution. So we will have the empty set as our solution. So you can recognize that as the empty set, null set, or you might just write no solution. Alright, so in example 5, we have, again, a complex denominator. We have two binomials. We can just multiply through by x plus 1 and x minus 2. And it's fine that if you can track visually this multiplication, you don't have to write out this next step. I am going to go ahead and write it out. So I'm going to write out x plus 1 times x minus 2 times x over x plus 1, and then x plus 1 times x minus 2 times x over x minus 2. It's equal to x plus 1 times x minus 2. Alright, so now I'm just going to cross out or cancel my denominators, and I'm going to end up with x squared minus 2x. I cancel the x minus 2's. I end up with x squared plus x. And then on this one, you have to FOIL all of this out. This ends up being x squared minus x minus 2 times 2. So we end up with 2x squared minus 2x minus 4. And then we're going to simplify and solve the remaining equation. So we can take everything to condense on the left-hand side and the right-hand side. First, I think would make it easier to simplify. So just x squared plus x squared is 2x squared. Negative 2x plus x is negative x. And then the right-hand side stays the same. Now I will subtract 2x squared on this side. And, well, I think it would make sense to just subtract it on the right-hand side, since we're going to have something left, or on both sides. Then we're going to add 2x. The x is over here. We can see that these will cancel. This leaves us with x on this side. I'm going to leave the -4 over here since we no longer have a quadratic. And x is equal to -4. Now, go ahead and plug this back in and check our solution. So we're going to check that x is equal to -4 works. We'll end up with -4 over -4 plus 1 plus -4 over -4 minus 2 is equal to 2. So it's -4 over -3, and then plus -4 over -6. So this is 4/3 plus 4/6 is equal to 2. Simplifies down to 2 is equal to 2. It checks. Our solution is -4. If you found this video helpful, be sure to hit the like button below. Subscribe to the channel to be notified of the next video release from Wildcat Academy. And if you have a question about how to solve rational equations, leave a comment down below. Be happy to answer those and help you out. See you next time.